Today, I picked a paper that introduced vision transformer for image recognition. At its heart, the paper asks one simple question. Can a standard transformer recognize images without using convolution? The paper is titled "An Image is Worth 16 by 16 Words Transformers for Image Recognition at Scale." Let's explore it together. To appreciate this paper, we first need to understand the problem it was trying to solve. By the time this paper was published, transformers had already changed the world of natural language processing. So it was natural to wonder, what if the same idea could work for images too? There was just one catch. Image recognition still relied heavily on convolution and neural networks. Even when transformers started appearing in computer vision, they were almost always used together with CNNs. So a simple question came up: what if we removed convolution completely? That's exactly the question this paper set out to answer. Now that we understand the problem, let's see how the idea works. A standard transformer doesn't understand images. It understands sequences. So before anything else, the image has to become a sequence. How? The image is divided into many small fixed-site patches. Each patch is flattened and then converted into an embedding that the transformer can process. At this point, the image is no longer treated as one large grid of pixels. It has become a sequence of patch embeddings. But wait, how does the transformer know where each patch came from? It doesn't. It can process the content of each patch, but instead needs to know where that patch belongs in the image. To provide that information, position embeddings are added. Now the transformer receives both the content of each patch and is positioned within the image. But one final question remains. How can the model turn hundreds of patch embeddings into one prediction? A relevant embedding called the classification token is added at the beginning of the sequence. As the sequence moves through the transformer encoder layers, this token gathers information from all the image patches. By the final layer, it represents the image as a whole. A classification head then uses that representation to predict the image category. Now, it was time to put the idea to the test. So, what did the experiments reveal? When trained on smaller datasets, vision transformer generally performed worse than convolution and neural networks. Then something changed. As the amount of training data increased, its performance improved dramatically. The message became clear. Given enough data, a standard transformer can learn the visual patterns it needs on its own. In other words, the architecture alone wasn't enough. Large-scale retraining was just as important. And with that simple idea, vision transformer opened a new chapter in computer vision research.